Hi class. Today we're going to just go over the type 1, type 2, type 3 briefly as a review, and then I want to look over the type 4 compounds, and then finally we're going to wrap up with naming some acids. So as a review, the type 1 binary compounds meant that you had some sort of metal, and then you also had a nonmetal. So if you look on your periodic table, hopefully you will see that these followed a trend that were pretty simple. So you have your nonmetal plus your metal. I should put my metal first, actually. Okay, so you have your cation, which are positively charged, with your anion, which are negatively charged. And we can depend on the different groups to help us along the way. So for example, we know that calcium is in the 2 plus column. And if we go and match that up with, let's say, fluorine, we put them together, you get calcium fluoride. But this is a -1, so we know that we need 2 of these. So our final equation here should look like this. Okay, so those are the type 1s. They have very consistent oxidation numbers. All of the group 1s make a +1, all the group 2s make a +2, etc. So you're going to follow along with your periodic table to help you with those. Type 2 can be a little bit more of the troublemakers because they deal with all the transition metals, or metals that have transition properties. And we're going to need Roman numerals to name these because they have multiple oxidation numbers. Okay, so let's do an example. We'll do iron oxide. We know that oxygen is a -2. We can count on that. So if this is in a 1-to-1 ratio, that must mean that the iron here is a +2. So we would name this iron 2 oxide. Okay, and again, we need our metal. Notice how we have our cation up here and our nonmetal for these. If you see charges, then you know that you need to follow the ionic compound rules. Okay, type 3, we get away from our ions just a bit. And these focus on just nonmetals. That's it, just nonmetals. If you do not see a metal, then you use prefixes to name these guys. So let's do this. N2O3. Nitrogen is a nonmetal, oxygen is a nonmetal. We do not see a charge here. So therefore we have to name this with our prefixes. If you look on the back of my periodic table, I gave you a little chart, and we would name this dinitrogen trioxide. Very easy. Okay, hard part is making sure that you keep all of these consistent in your head. Okay, now moving on to our type 4. Let's see if I can insert another page here. Oh, let's see. I don't think it really wants to right now. But type 4, I'll just erase all this. Basically follow the same conventions as the type 1 and the type 2 because we're back to the ionic compounds. It's just that now we're going to deal with polyatomic ions. Okay, so you're going to have to look on the back of that periodic table that I gave you once again, and I gave you a list of the most commonly used polyatomic ions. But just in case you care, here are a few right here that you can use, slow down and pause and take access on these too. Okay, so these are just widely used polyatomic ions that we need, and the type 4s are basically the same. We definitely need our metal with our nonmetal, okay? Or should I say the cation with the anion. So these, though, are dealing with these polyatomic ions. So I'm going to put 2 together here. Here we have NH4, and then we have C2H3O2. Well, if you look on your back of your periodic table, you'll notice that NH4 is ammonium. Okay, and it also has a charge of +1. This here is acetate. You'll have to look at the back of your periodic table there. Acetate has a -1. So we simply name this ammonium acetate. Okay, these aren't too bad as long as you keep them all straight. Okay, let's go back here and we'll work a couple. So let's look at calcium sulfate. Okay, this whole entire structure here, the SO4 is a 2- charge. Calcium is a 2+. We know that because we can just look on our periodic tables. In group 2, it always makes a 2+ charge. Okay, so we put these two together. They're in a 1-to-1 ratio. They're happy, CaSO4. However, if I take calcium nitrate, this is still +2. Okay, this is now -1. Okay, we need to balance out. So we need to have a +2 and a -2. So what you can do here is put your parentheses around the entire nitrate ion and give it a 2. That 2 goes to that entire entity there. Okay, so now you have 2 times this -1. You have -2. When balance that out with a +2, and there you have it. Okay, you still might get some type 2 in here. For example, I might get, let's say, iron sulfate, let's just say. Okay, so you still, because iron has multiple oxidation states, you still may have to use your Roman numerals here. Okay, we can't, it's one of those transition metals, we can't count on its charge, so you have to let us know. So we know that sulfate's a 2-. How do we know? Look on the back of the periodic table and find SO4. You'll see it's at the 2- range. If this is in a 1-to-1 ratio, that must mean this is a 2+. So if you were to write this out, don't forget, you have to write iron 2, and then you go ahead and name sulfate. So sometimes you have these type 2s coming back into play. If you see a transition element, make sure that you are indicating its correct charge by giving it its charge in its Roman numerals here. Okay, so don't forget about all these different things that you're learning. So that's type 4. There's a little document on under modules that you can go through and work some of those problems. Some of you have already started them in class, so if you need any extra help, just let me know and I'll come around. Okay, the last one that we're naming are acids. These are also fairly easy, but you just have to keep a few things in mind, okay? We have 2 different types. The first thing we're going to look at here are these binary acids, which are the simple ones, okay? So you're going to see H a lot. This H plus signifies an acid, okay? That means it gave off some hydrogen protons running around, and it's going to be able to attach itself to an anion. So if the anion does not change oxygen, then the acid is named with the prefix hydro, and then we put an ic. Remember, we were using "ide" a lot. We're going to get rid of "ide" and we're going to put "ic" at the end, okay? And then we name acid after that. So these are just simple elements on the periodic table. They're not polyatomic. I know cyanide seems like it is, but we treat it like a binary simple acid, okay? So if you see this, you have, we named the hydro first, hydro, and then we said that we're going to get rid of the chloride and we're going to make a chloric acid. So you name these if you just have a simple element after the H. Okay, you always get the hydro first, then chloric, and then acid. And notice here we have a cyanide, so you would just name it hydrocyanic acid. Same with this one, hydrosulfuric acid. Okay, so let's look at a couple more. So these are just the simple binary acids. Okay, well, that was supposed to be a review here. So here's just a couple more. Notice that none of them contain oxygen. If you see oxygen, then we call those oxyacids and they get named a different way. So these are just simple binary acids. Hydrofluoric acid, hydrochloric acid, hydrobromic acid. Just notice these simple elements basically all by themselves, exception of cyanide. I know there's 2 of them there, okay? So hydroic acids. So you have to know about these binary acids that do not contain oxygen. However, sometimes you do have oxygen in there. We call these oxyacids, okay? So if the anion contains any type of oxygen, then we name it a little bit different. Usually we see things like sulfate or we see sulfite. If you see 8 at the end, you change the ending and you put an ic on it instead if you're naming an acid. So ate goes to ick. Sounds kind of funny. If you have ite, like sulfites, we're going to change its ending to us whenever you're naming these acids. We do not say the word hydro first. If you see oxygen, eliminate hydro from your vocabulary. Okay, so this one here is an acid. How do we know? It starts with hydrogen, which is good. Okay, so this right here is sulfate, right? So we know this is an acid, so we're going to give it the acid naming conventions. So since this is sulfate, I'm going to change that ending to sulfuric. Okay, I'm not putting the hydro, as you can see, sulfuric acid. So if you have an oxygen in there, you do not use the word hydro as a prefix. You start at the actual polyatomic ion, change its ending, and then add acid at the end. Okay, here's another one. We know that this is an acid. How? Because it's starting with an H3. You might be wondering, where's that H3 come from? Well, remember the phosphate is a 3 minus, so we need a 3 here to balance that whole thing out. So now we have a 3 plus and a 3 minus. Okay, we don't use hydro because that's for the simple binaries. We just start here with phosphate. We get rid of that 8, and we switch the ending to ick. 8 goes to ick. That's what I mean here, okay? So now we have phosphoric, and then don't forget to put the word acid at the end. Same with this one. It's an acid because it starts with H, okay? This was acetate. 8 goes to ick, so we put acetic acid, okay? Acetic acid. Now notice, if you lose an oxygen, the 8 goes down to ite. Okay, so it was SO4, it's now down to SO3, and so it's ite at the end here. So I said before, ite goes to us. Okay, so now we name this. This is sulfite. I get rid of the ite, and I put us there instead. So I would name it sulfurous acid. Same with this one. This is nitrite. It was nitrate. NO3 is a nitrate, but now we have NO2. It goes down by 1 oxygen. So ite is lower than 8, and then we put the ite to us. Okay, so these just take a little bit of practice, but they're pretty easy once you get the hang of them. So there's just like another review of here. The higher oxygen has nitric, 8 goes to ick, ite goes to us. This was sulfate, so it goes to ick. This was sulfite, so it goes to us. This was phosphate, so it goes to ick. Okay, and this was acetate, so it goes to acetic acid. Okay, so there is a worksheet. You can do a few of these to get the hang of them. I'll do a little bit in a minute with you, but this might help to wrap things up. So if the anion contains oxygen, you're going to check the ending of that anion name. If it has an 8, it goes to ick, and then add acid at the end. If it has an ite, you're going to put OUS at the end, and then have your root like nitrous acid, okay? If it does not contain oxygen, you're going to start with the prefix hydro, you're going to add the ick, and then you're going to finally put acid. So hopefully that little diagram there will help you. Okay, this is more of an honors level topic. However, if you want to follow along, you may. Sometimes you have, higher up than even what they're showing here. Like we could have, let's say, chlorates, which is ClO3, but we can also have perchlorates, okay? So if you go up by 1 oxygen, then you would use a per. If you go down underneath the ite, then you would use hypo, okay? So let's take a look at some of these here. It looks a little strange, but you can just stop this here if you want. This is just, a wrap up of what we were just talking about, naming the binary acids, okay? Naming the oxyacids, we already talked about this, but this one here is just maybe one step further. So usually it's SO4, right? So that would be in sulfate, so it goes to sulfuric. But if you'd have 1 extra oxygen, then we use the word per in front of it, so it's per sulfuric acid, okay? Ite still goes to us, so sulfurous acid. But look, now we're down even more, down 1 more oxygen. Okay, so we go to hypo. So in order, we go from per to ate to ite down to hypo. Okay, so that's the order if you have multiple oxygens. Same with this one. If this were NO4, we would have per nitric. This is just nitrate, so it goes to nitric acid. Ite goes to nitrous. We ran out of oxygens here, so now it's hyponitrous acid. Okay, you still keep the S for these hypos, by the way. Okay, so you can look over these again. This is more of an honors level thing, but if you want to check it out, feel free. So we're going to just name a few of these here together. Hopefully you saw this hydro, so that is your clue that you're dealing with something a little bit more simple here. So it's just HBr. Okay, sulfurous, well, we know that this is sulfite. Okay, so that must mean ite goes to us. So this is what we would have here. Okay, let's look at here. Hydroiodic acid. Well, that's simple. So it's just H. This would have been the iodic, iodine, switches to iodic. Okay, so give these a try. Use your periodic table on the back. And so once, like this one, I'll just do this one because it's here. So we have H3PO4. I know, I'm sorry, this is phosphorus. It's going to be PO3. Get rid of that. That's a 3. Yeah, PO3. How do I know that? Because this would have been phosphorite, and then we switch it to us at the end, so it must be PO3. However, this is still a -3, and to balance that out, I need the hydrogen's a +1, so we need 3 of those. Okay, so don't forget about balancing out the actual compound or molecule whenever you're finished up. Okay, we can go the opposite way. Notice here they're kind of together up there, but this is a little bit different because this is PO4. So hopefully you have realized that that would have been phosphate, but we're going to name this phosphoric acid. Okay, so give these a try and then turn it in whenever you are finished.